you think of the language as just kind of a static tool that you're using, and it's not. It's growing, and there are people that are researching it. It's really important to get out of the office and be exposed to those people and how they're making changes to the very tools that we use.
Cool. Hello, everyone. Welcome to my talk today. My name is Luis. For you who don't know, for those of you who don't know, I'm a tech lead in the content team at JFrog. And if there is something we care about, especially my team, is binaries. And what I'm going to talk about today is actually a collection of learnings from, I don't know, the past 3 years working at the content team at JFrog, but also when I was a C++ developer before that. But first, I want to clarify what I'm not going to be talking about, which is this isn't a talk about whether or not we should have an ABI break or the benefits or disadvantages of doing so, or presenting arguments in favor or against doing that. I don't have a horse in this race, right? At least from my perspective, what we care about is developers not facing issues linking their programs, right? But what this talk is about, after giving you guys a brief context, initially I thought, oh, this is going to be a hypothetical of if we broke the ABI today, what would happen? How would the ecosystem react? Or what is the tooling adapted to be able to do this? But working in this presentation, I kind of like eventually switched it around a little bit, which is first, I'm going to be discussing examples of how we've dealt with C++ ABI breaks in the past. But most importantly, how we're still dealing with link incompatibilities almost daily, depending on what team you're in and what libraries you're using. And lastly, I'm actually going to talk about how some of the tools that didn't even exist or barely existed 10 years ago could actually be key to facing a new ABI break in the future, if and when it comes. I think it's more of a case of when rather than if. But first, let's talk about very briefly about what's an ABI. It's application binary interface. And I think there's a really good paper about this, and I think from a CppCon talk for about 4 years ago as well, a very, very detailed on what the ABI is. But for me, the key takeaway here is when you have a built translation unit, a composite translation unit, is how it talks to entities in different translation units, whether they are built from different source files with the same compiler version, or whether part of that code is in a library, may have been built with a different compiler or a different compiler version. So details, if you want more technical background, is in this paper or other resources as well. And the next bit is, why is it a concern of the C++ standards committee whether or not to break ABI? The ABI is actually outside of the scope of the standard. The standard covers mostly the language and the standard library, which includes templates, classes, functions, anything used to describe a standard library. And the ABI itself is actually very platform and vendor specific. We have different ABIs for different operating systems, CPU architectures, like the compiler vendors as well. So that's way outside of the scope of the standard. However, the things from the standard library that are in scope for the standards committee, changes to some of those things can actually result in forcing the compiler vendors to have to break the ABI in a future release if they want to be standards compliant. So, but then again, even if they have to do that, because ABI is platform and vendor specific, so is the way of how the developers are going to experience that. What are they going to have to do? So rather than talk about the different ways in which we can implement an ABI break, whether it's we're gonna call the standard library a different name, right? Which has happened before macOS when they switched from one to another. Or maybe we're gonna bump the SO name version, things like that. I want to talk about this from the perspective of the developer. How do we experience an ABI break? And usually, I'm gonna go from from more preferable to less preferable, right? The first one would be an obvious linker error. This is the most common way of signaling this is when I'm trying to link objects that have been built with like different ABIs. It would be very useful when the linker told me, oh, hey, you're mixing objects that are not compatible. This is not going to work, and have an error right there and then. What usually happens, and most of the examples that I'm going to be showing today, is very cryptic linker errors. This one, a lot of you may be familiar with. Some of you may not, but I will clarify later. But there are instances when we have an ABI incompatibility, that we may actually have runtime errors. We're going to get a seg fault that may be a little harder to diagnose and trace back to an actual ABI compatibility. And that's if we're lucky. If we're not lucky, the program is going to run. It may exit correctly, but it's not actually going to behave the way we expect. I've seen issues. If you try to mix the OpenMP runtimes in a bad way, it's just not going to work. Or actually, it's not gonna do the calculations correctly that you're expecting. So it's not a fun thing to see, to be honest, because you don't have much information about this happening. Late last year, I think it was, there was a paper that was published by the Language Evolution Working Group by Herb Sutter, which is reaffirming the design principles for future C++ evolution. This was, I think, a bit of a contested topic as well, because I think for a number of years, there's been an intense debate on whether or not we should break the ABI, or whether we should do it sooner rather than later. So I think this paper was good in the sense that it actually expresses that as a principle, as a design principle for C++, to actually retain ABI compatibility, at least indefinitely. The way this is expressed in that paper is kind of adding to something that was already there. You know, C++ is link compatible with C. So the design principle is that it should also be link compatible with previous C++. And I'll cover that in a second. And I also want to highlight that one that we used, and I think it's also very, very useful for all of us in the language, is that new C++ code should be should be source compatible with all the C++ code. Like new standards should still be compatible, right? But when we talk about retain link compatibility with previous C++, what do we actually mean by that, right? Bear in mind that, remember, the ABI is completely outside of the scope, so the implementation that the compiler vendors do about this is also way outside of the scope. So here are some examples, again, trying to think as a developer, right? When we're talking about retaining link compatibility, does that mean that if I have the same version of the compiler, I should be able to link, I should be able to build some source files with C++26, hypothetically, and link with other source files or libraries that would build with C++23? I think we can all agree, at least with the same compiler version, then the answer should be yes. But it gets a little trickier when we're mixing binaries that we build with one compiler version and linking with binaries that we build with an earlier compiler version as well. Or for some teams, it's important to actually be compatible with binaries that we built like many, many years ago, like 20 plus. And even the other way around is like, I may have a library that uses C++, a newer C++, like 26, in its implementation, but the actual interface is still C++17 compatible. I've seen some libraries. We have quite a few of those in Content Center as well. So what are the limits to the actual statement of retaining that link compatibility? So next, I'm going to be talking about, and you see a pattern in this talk, about past C++ ABI breaks and how developers experience this, right? I think one of the most famous ones is how the Visual C++ compiler, with every release of Visual Studio until Visual Studio 2015, they would fully break the ABI compatibility. If you had objects that were built with Visual Studio, say 2005, you couldn't link them with a program that was built with Visual Studio 2010 in a way that C++ objects could interact. There were workarounds, but you shouldn't have objects crossing what they call the CRT boundaries, the runtime boundaries, and that caused some problems. So just to illustrate how often or frequently this happened until Visual Studio 2015, this is the Visual Studio releases until 2015. And to be honest, it looks like they were breaking the ABI very regularly every 2 to 4 years. So Sometimes I do find it surprising when people discuss whether we should break ABI or not, because this was happening quite frequently back in the day. Although, on the other hand, having been a Windows developer myself, it was a bit, I wouldn't say frustrating, but it could be disruptive for some workflows or some teams as well, how frequently this was happening. This is an example of a linker error that you could get if you were mixing and matching different runtime versions. And to me, as far as linker errors are concerned, this is probably one of the friendliest ones that you're gonna see today. One of the most frustrating things about this one is that you had to keep a map in your brain of the different versions of Visual Studio depending on what it was. So Visual Studio 2010, I think that was a lucky one because it was also Visual C 10, right? But the other ones is like, oh, Visual Studio 2012 is version 11, but the error that I'm gonna get is gonna reference 1700. This was actually, in my opinion, that was the most frustrating thing. About the linkers, having to remember all the different versions depending on what specific component we're talking about. One thing, and this is before the era of C++ package managers like Conan and VC Package, you may have teams that had to maintain binaries for multiple versions of Visual Studio, and you would see subfolders like this. You would see VC11, VC12, VC14. This was fine. Those binaries were compatible with that specific version of Visual Studio. Perhaps you had to spend additional time building them. If anything, the biggest problem is that like tooling, like let's say CMake, if you do find package OpenCV, which one does it find, right? If you're not careful about which one you're exposing to CMake, that's when your developers would experience like linker errors or runtime errors and things like that. So that's just the summary of the Visual Studio breaks before Visual Studio 2015, although I'll talk about later about the current ones that we are still experiencing to this day. But I'll move on to what happened to libstdc when GCC 5 was released. They decided that it was finally time to have the implementations for stdstring and stdlist to be actually C++ 11 conformant with the standard. But rather than implement it in the way that Visual Studio was doing, which is have a sort of wholesale ABI break, what they did is had the newest version of libstdc++. What it had was the implementations of both. And they used nested namespaces to do this, so the mangling of the symbols inside the library were different. So these require no source changes at all, and most ABI breaks don't require any source changes at all. The same library was backwards compatible with both the old ABI and the new ABI. The only problem that you could have, and I think this was very common back in the day, is when you were linking objects that were built, some were built with the old ABI and some were built with the newer ABI, and you would get linker errors. And the way those linker errors look like, and this is something that I got from Stack Overflow, where somebody's trying to mix a library that was built on Ubuntu 14.04 with a library that is being built on Ubuntu 16.04, so a 2-year Ubuntu LTS jump. And you will see a link error like this. Now, if you're an experienced C++ developer from back then, these were very common and you knew exactly what to look for, but you had in the soup of errors, you had to look for ABI : CXX11 or something like STD : __ CXX11, right? To the point where the rest of the error was almost irrelevant. The information that this was giving you is you have to do one of two things. Either you build a current object with the old ABI or you rebuild the older object with a new ABI. This is exactly how it was documented by GCC in the page that I have here on the left. It's like, if you see errors related to this, that mention this is what's happening, right? And it gives you instruction on how to rebuild with one ABI or the other. But reading the fine print, what they said is like, for a given GCC build, the default value is baked into that build. You could have the same version of GCC on different distros actually be using different ABIs. So if I'm not mistaken, I think Ubuntu fairly quickly decided to use a new ABI, but obviously for compatibility reasons, Red Hat was stuck, even for GCC 5, on the old ABI for a couple of versions, if I'm not mistaken. So bear in mind, what I'm trying to illustrate here is don't trust that binaries built by different versions of GCC are actually link compatible with each other. That's not necessarily the case. But another issue with stdlib C++, perhaps a less common one that I experimented with the other day, but I remember actually seeing this, had to do with the implementation of a std file system. For GCC 7, this was still fully experimental. So the compiler flag was not even C++17, it was C++1Z. The header was include experimental/file system. The namespace had the word experimental in it. And if you wanted to create a program and link it to use the file system functionality, you had to actually explicitly link this to C++ file system library. Now, GCC 8, they changed this. So the compiler flag was different. The header no longer was under the experimental subfolder, and the namespace also was just like what the standard says, std file system. But you still had to link the additional library. So that changed in GCC 9 when the implementation was actually included as part of stdlib C++. Sorry, I tapped this on libstd C++. And do you think that if I build a binary that uses the file system functionality with GCC 8, I could then reuse a binary with GCC 9? I tried. So let's say I have a library, a shared library. I build it with GCC 8 on a version of Ubuntu, and I follow the instructions to use the file system functionality. And then I try to link a program that uses the functionality from that library. And in its interface, it was passing, I think, a std file system path object, right? So when I tried to run it, I got an immediate segmentation fault, right? The reason for this, reading the finer print of GCC documentation, is that the actual ABI for C++17 features was not stable until GCC 9. So, and what was happening is that file system library that you needed in GCC 7 and 8 was actually a static library. So the objects of that were inside my shared library, and they were probably conflicting with the ones from the actual standard library in GCC 9 or above. So raise your hand if you're using GCC and C++20 in your projects. Quite a few people. So according to the documentation of GCC as of today, it's still experimental. So technically, there could be an ABI break for C++20 in GCC in the future, right? I would expect that at this point it's unlikely, but bear in mind that that's a reality today, right? And then lastly, for GCC and even in macOS, these were less recent. The last time there was an actual full break of libstdc C++ was in 2004. It was fully incompatible with the previous, and everything had to be rebuilt, unlike the one with the C++ ABI, where some things had to be rebuilt, depending on what they were using in their interface. But the old version could still be installed, and even to this day, at least on Intel systems, you could install the older version in the system, and programs would run on the condition that you don't load both versions in the same process. And then macOS, I think it was around 2013, they transitioned from libstdc C++ to libc++, I think very successfully. I don't remember much issues with this, although there were quite a few. But beyond the actual linking compatibilities that are in the scope of compiler vendors, we have others that are affecting developers or have affected developers in the past. I'm sure some of you may remember this one. At some point, I would say in, I don't know, 6, 7, 8 years ago, Linux distros switched to generating programs as position-independent executables. There were security reasons behind it. But if you had static libraries that had been compiled before that was the default, then you would get a linker error like this. Now, as far as linker errors are concerned, the recompile with fby is the friendliest linker error that I'm going to show you today, because all the others that come later, believe me, they're not. So I'm sure you remember this. And the solution to this was, unfortunately, you have to make a decision. Either you rebuild the old library from source as position-independent code, or you just choose that your executable is not going to be position-independent, and everything is going to be loaded at, I think, the 0 address, if I'm not mistaken. But you're probably giving away that sort of security feature. There was another one that we were getting in Content Center reports, I think, like 2-3 years ago. A specific version of glibc removed some symbols from the library, but surprisingly, it only affected if you had like static libraries built that use the fastmat functionality. So if you were trying to use it in newer systems that had newer glibc, it just wouldn't link. It was telling you that there were missing symbols. And I looked into, I was researching into how this happened, and I found this email in the glibc, I think, mailing list, where one of the GCC maintainers was actually saying, if you have static libraries that were built with old headers of older glibc, that's not actually a supported backwards compatibility case. To be honest, I was a little shocked. I didn't know this. And it turns out that a lot of the backwards compatibility tricks that glibc does involve the linker and symbol versioning and things like that. But when you create a static library, the linker is not even involved. So when you were trying to link it in the future, those particular binaries wouldn't link at all. So you actually had to rebuild them or do some tricks to disable some functionality. So that was interesting. I think I found on Stack Overflow as well, people were saying, well, you can sort of define the symbols yourself, because there's a global symbol namespace, that's a different story, to call the actual implementation present in the current version. So there were tricks, but I always find it funny when we try to say that there's long-term backwards compatibility when it comes to ABI. In C++ maybe, but we're still affected by things completely outside of the scope or the control of C++ maintainers. So as a summary for these past ABI breaks, and I think some of these are the more important ones, MSVC was breaking ABI roughly every 2 to 4 years with every version of Visual Studio until 2015. We're still compatible with that. libstdc C++, we have the C++11 ABI that was released with GCC 5. And keep in mind, C++20, according to the documentation, as of today, is still experimental. I'm hoping that the ABI will not break, but who knows. And then I think you're all familiar with this. If you have binaries built with GCC on Linux, they're not always link compatible. You may have issues with the actual versions of the glibc symbols that they have, or like I show you, was this, or even the same version of libstd C++ on different distros might not work, and you get incompatibilities completely unrelated to C++. Another one that I saw the other day is not even strictly ABI, but it still introduces an incompatibility. I think glibc 236 removed, it was generating binaries with 2 hash tables formats, so the same hash table in 2 different formats, and they removed one of them, and they only kept the GNU one. And this broke the ability to run and start certain games that were using like anti-cheat components, right? So I was researching into this, and I found a blog post. The title I found super interesting, which is Win32 is the only stable ABI on Linux. And it's like, that's the Wine emulator, I think. So, well, Wine is not an emulator, but that's actually not necessarily a lie, just to say the least. So it definitely, there were some emotions involved in that one. Now, I want to talk about current C++ ABI issues that go after those points that I mentioned in the past when the compiler vendors were breaking ABI that developers are still experiencing today. So retaining the incompatibility with previous C++, we have the C++ standards committee and the compiler vendors. I think they're doing a very good job on keeping things stable. I think it's a good goal to avoid disruption, right? We don't want disruption. But on the other side of this, we have library authors, so not the standard library, where you know what? I understand your concern with the C++ standard library, but I don't have that concern with my library. So, and not only that, we've been giving library authors every single tool to actually have APIs gated on features from either the C++ standard or the compiler version, or whether there's some include or not, depending on the version of the compiler as well. And this actually leads to the same header files resulting in incompatible ABIs when they are linked in different translation units. So as an example here, let's say I have a header file that has one of those macro conditionals, and the binary library is a shared library that I built with C++14. And in my code, because I really like C++20, I just include a header file and I use C++20. If I have some of those features that actually result in a different API, even with no source changes on the consumer side, on the caller side, I'm going to be getting linker errors. And this is more common than you realize, and I'm going to be showing you some examples. Now, one way of dealing with that is, and I think I've seen this in the VC package maintainer guide, to avoid having headers like that and actually hardcode the decisions in the header file so that they're the same both for the library when you build it and for the consumers as well. So that should mean that even if the library supports multiple implementations for the same classes, for instance, like using the library, building a library and consuming it from different levels of the C++ standard or different compiler versions, it should still work. So I'm going to show you an example with Absal that has this functionality as well. They actually provide a file, options.h, that if you modify it and you hardcode the decisions, it should achieve that binary compatibility across different versions of the C++ standard pertaining to the actual binary of Absal that you compile, or at least that's the promise, right? So that's what this header would look like, and then in the file that implements, let's say, the variant, Absal variant, right? Well, if you're not using the standard library implementation, it's going to have its own implementation right there. So recently, and this was about 4 or 5 months ago, there was a version of gRPC that was released that requires C++17 as the minimum, and it wouldn't build otherwise. And I had binaries for protobuf and Absal that I had built with C++14. And I also had that options.h hack that it was hardcoding the decisions of what classes it was using, what was the actual implementation for stud variant, right? And it was used the stud variant implementation provided by Absal rather than the standard library. So I tried to build gRPC 172 and I couldn't even compile it. We're not even talking about linker errors. I was getting the most cryptic, well, I think they all are cryptic when it comes to templates. It's my kryptonite. I don't understand it, but what I could see, and I highlighted in different colors, is that gRPC was using stud variant, but then some of the types that I would have expected to come from the standard library were actually coming from Absal. So I wonder if it was ADL or something getting mixed up there. What actually happened, and I could trace it to the actual commit, was this. They moved to requiring C++17 as the default. And following that, they said, you know what, because we know that we are in C++17 and we know that stud variant is available, let's use that in our code. So rather than using Absal variant in that namespace, they moved to stud variant. And that actually broke the encapsulation that Absal variant was providing, which was causing my compiler issues as well. So encapsulation went out the window because they just simply assume, you know what, we are in C++17. We're not even going to consider that Absal was built with anything less than that, with that support. So, okay, I thought, all I need to do is rebuild Absal with C++17, which I did, but I completely forgot about protobuf, and I just continued using the binary I had built with protobuf with C++14 and Absal with C++14. So the result was it compiled, right? But, and let's see if I can get to the video here, so you can actually see what happened next. Linker errors. And it was not just like a little linker error, it was a constant stream of linker errors. So the compiler was happy, the linker wasn't, and it was just a string of missing symbols, right? So this was a little puzzling at the beginning, but eventually once I built Absal, protobuf, and gRPC, all of them with C++17, it all magically worked. Obviously, read the manual. Absal says that this is how it works, right? But it also says, but you can use the options.h for static configuration. That didn't work. That didn't work because gRPC actually made a decision that completely broke that. And shortly after that, gRPC also updated their README that, yes, you should be consistent with the use of the standards, of the standard level. But I know what some of you may be thinking, oh, this is Google, this is Absal. This is terrible, not my words, but I read it online. But it's not just Absal. I've seen this with multiple other libraries. In Content Center, I think we have like different implementations of stud optional, some of which actually have very similar functionality and work the same as Absal. The first time I experienced something like this wasn't even Absal, it was with Boost. So we were moving in the team that I was at, we were moving from C++11 to C++14. And I thought, oh, we can just use C++14 in our code, enable that flag. Boost wouldn't link because there was a type or a function somewhere that had those macros that if you're in C++14, do something else. So it's not just upsell. This is, I think, optional light. Again, if available, if you include this header and if it's available, std optional is going to be used. This is how you get ABI incompatibilities between libraries. There's more, and this one also we found in upsell, but it was not their fault. As you know, if you have an inline initialization inside one of these, it is required prior to C++17 to declare it like this in order to actually define the symbol. So what happened was if you build lib.cpp with, say, C++11, and then you build main.cpp and try to link them with C++17, it doesn't link, right? And I found this in, actually the explanation for this in a GCC bug, where I think the discussion goes, am I expected to be able to link objects built with C++11 and C++17? The expectation is yes. Does it work? Not in this case, right? And I don't think it's the solution. It's still open as a bug. I think they discuss different ways in which the symbol tagging should work for the linker to decide on one of the symbols, but it's actually broken, at least for this. So this is something that users may or may not be experiencing. Another one, completely unrelated as well, is that Windows developers that are using Visual Studio, they're actually dealing with like 4 different incompatible Windows runtimes. And I would like to say that this is happening mostly without issue. But if you're not careful, and I think this has to do with either the tooling that you're using or the toggles that you're tweaking your Visual Studio projects, you're going to get a very friendly linker error. This is good. What's less good is that this works well when you're dealing with static libraries or object files, but if you're loading DLLs, it is possible to actually load the 2 dynamic runtimes in the same process. So this would be the optimized one and the debug one. And I had a program, I did a toy project to test this, where I ran the program and it was not crashing at all. It was just not giving me the results that I was expecting. So again, this is something that I mentioned earlier. There are things that can happen that you're not even gonna know because it doesn't crash. Like a crash is good, a linker is good, a crash is less good but still good. When it doesn't crash, it doesn't do anything properly, that's the worst possible case. Now, remember that I mentioned earlier, Visual Studio, they have remained backwards compatible since Visual Studio 2015. And you are able to link objects and libraries that were built with different versions on the condition that the linker must be from the version of the toolset that is as recent as the most recent one from all the objects that you're building, right? When that doesn't happen, because you cannot guarantee that, you're going to get cryptic errors like this. And this one, this happened last week to us while we were working on the demo that we had in the booth there. And you may see upsell there. Upsell has nothing to do with this. It was the fact that, like, if you had a slightly older version of the Visual Studio C++ toolset and the linker that was older than one of the objects that you were trying to link, you got errors like this. So Visual Studio at the moment doesn't have a way of telling you, hey, this is what's happening, you should fix it, you should maybe update to a newer version. So I was Googling this error, and it actually happened, it was reported by a lot of people using GitHub Actions. Apparently there was some library that they were trying to link that was built with a newer version than the toolset that was available in the GitHub Actions runners, right? But you don't know. This is some internal implementation thing that, like, if you don't know, you don't know. And then this happened to one of my teammates because they did have the most recent version of the Visual C++ toolset. What happened was that there was a bug in the installer that, depending on what order you install things, it will default to an older one. So it's very difficult to trace. So this is still happening. Another one that, remember, this is guaranteed by the, at least the documentation of Visual C++, that each of the newer toolsets is still backwards compatible. Since Visual Studio 2015, it's still backwards compatible with the previous, except when it isn't. And we've had issues like this reported in Content Center as well, because we do provide binaries for some of the libraries. And I saw this the other day as well reported by a user that say, ideally, we would be on the latest, but we have a closed source library, But there was an actual ABI break. And I've seen this before, like if you follow the minor versions of the Visual C++ compilers, that sometimes there's unintended ABI breaks that they revert in later versions, but at that point the damage is done, or they are known and documented, but they don't affect many people, but they still happen, and you still see like very encrypted linker errors. Another one that I've sort of mentioned before is, let's say I have GCC 13, and I have 3 different Linux systems. If I build a shared library with GCC 13 in any of this, is it actually going to work properly on the other 2, right? The answer, at least for these ones that I chose specifically, I think the answer is no, right? You really have to know. So GCC 13 is probably going to have the libstdc for GCC 13, but on Red Hat 8, you're gonna have libstdc, the shared library from an earlier version, and if you download the newer toolset, anything, the difference between the versions is going to come in a static library that's going to be linked in stuff like that. So they're not necessarily going to be compatible. And Alpine uses the muscle libc runtime, so they're probably going to be incompatible altogether. But a lot of developers don't actually know this. They just focus on the file name, and if they like need a library with like libfoo.so, they're just gonna find it somewhere, I don't know where, and they're going to try to link it, and things are not going to work, which leads me to this really good blog post that I found the other day. I mean, they use the word atrocious here. I'm not sure I would use that, but it's actually a really good article like explaining all the different binary incompatibilities that you may find where you're trying to build libraries that actually work across multiple systems. Although I would like to point out that I would try to separate the concerns of runtime concerns, like is this library going to actually run on a certain system, from the can I link it in from different compilers, compiler versions, or different C++ standards, right? I think those are slightly different. While Microsoft, for instance, they broke ABI every 2 to 4 years, you can still run really, really old binaries, even in current versions of Windows. Even on the Windows on ARM that has the emulation, like you can really do this. So as a summary for this, macro conditionals cause ABI incompatibility between libraries that developers experience. Sometimes it's documented, a lot of times they aren't, but it still forces developers to have to investigate why it's happening, and they have to rebuild things from source. And then the other one is like, despite the better intention of the compiler vendors and the standards committee, there are things that just don't actually work in terms of like being ABI compatible, backwards compatible. Another one is like, at least for MSBC, and I would like to say we successfully deal with multiple incompatible runtimes, because it's true. Like when you if you're building debug libraries, you are doing this. I think the tooling for this, the naming conventions, they're not ideal, but it kind of works for developers. To me, the worst bit is the crypted linker errors. I kind of wish that somebody just like got the output from the linker and like, I don't know, feed it to train some AI to actually tell you what you should actually do. Because in most cases, or in some cases, it could probably tell you. And again, the last bit is like on Linux, the situation with compatibility is not great. You cannot probably even guarantee compatibility on different versions of the same distro, depending on which distro you have. Now, and remember I mentioned earlier, it's not a matter of if, but when. Virtually, like all of the 3 main implementations, they already have like a list of ABI breaks that are coming. So Microsoft has, and you can see on GitHub as well, because it's open source. They're planning all the little ABI breaks that they're going to have, all the features that require an ABI break. And I think in the Visual Studio developer community, there's actually a feature that you can vote. People are actually requesting an API break. I was surprised by that. LLVM, libc++, you can also build libc++ with an ABI incompatible changes from the other, and this is good. You can actually do this. And actually, libstdc has added more ABI breaks since the GCC 5, the last famous ABI break. More minor ones as well, but they are documented if you want to look at the documentation. So the last thing that I want to be talking about is how developers are dealing with incompatible ABIs. And I'm not talking about how we would deal, what would we do if there was an ABI break in a newer C++ standard, but what's happening today, right? And what I would like to point out is like, this is not good, right? On the scale of the linker errors or that were more evident, the cryptic ones, the runtime errors, or the worst case scenario where programs run, but they behave incorrectly, I think there's room for tooling to either give you a much earlier error that, hey, you're about to link incompatible binaries, I'm not even gonna bother, right? It's great if it happens 10 seconds into the build. It's not so great if you have like really large programs because linking usually happens at the end. But the better case scenario is that there's no errors and your build is structured in a way that it just works because it knows what can be rebuilt, right? And I think tooling today is able to get us there, and I'll show you some examples. We have good. You're using the package manager or a build system that will like alert you of incompatibilities before it even starts the build. Probably better is, you know what? I know I have pre-built binaries. I'm not even going to consider them. I'm only going to consider binaries that I know that are compatible with the target, with your build target. And if I don't have them, I'm just going to tell you I'm missing a binary for the desired configuration. The best case scenario, if you have the ability to rebuild things from source, is that your tooling is able to just build a set of compatible binaries and you don't have to deal with this. Maybe the worst pain point here is the extra time that you have building those additional binaries, but I think it's still much preferred than cryptic linker errors. And then a bonus for like C++ developers as well is like some of the tooling actually allow you to build more special binaries, like LTO, for instance. If you build libraries with LTO enabled, they're only compatible with the specific version of the compiler. I think some of the sanitizer runtimes are also ABI incompatible across different versions as well. So if the tooling lets you build those as well, that'll be great. libc++ on Windows, I think it doesn't guarantee ABI compatibility across versions of Clang. So far yet. So there's that. So I think that would be a good outcome for tooling, right? So let me start with one that actually implemented one of these, which is Homebrew. When macOS switched from libstdc to libc++ back in the day, and I think it was around 2013, well, Homebrew was affected. Like you may have had before certain updates of Xcode, libraries that were built with the old runtime, and Homebrew, when you were installing new things, it would tell you, hey, I will refuse to install software if it was built with an incompatible library. This is still much better than getting a linker error. It may not be ideal, but it's better. Linux distros as well, they are really good at isolating all of the system libraries that you're able to see. And I call this compatibility islands, right? Different versions of the same distro or different distros, most of them have a system package manager. They're really good at isolating the compatibility binaries. So if we look at the apt sources configuration for Ubuntu, the words noble and the architecture, that's all it takes to sort of describe the compatibility layer here, right? So that actually means, okay, this is GCC 13 that defaults to C++ 17 using glibc 2.39. Technically, if you were to find a different Linux distro that targeted the specific versions, they are more likely to work. So if you can sort of back translate the information of the version of Ubuntu to the specific versions, you may be luckier when it comes to using binaries that are built in different environments. VC package, for instance, it does have the ability to define triplets. They have some built-in ones. You can add your own custom ones as well. So I'm thinking if we introduced a new C++ standard or a new compiler version comes along that breaks the ABI, I could, duplicate the relevant one and be like, okay, ABI new, ABI 2. You can do this already if you wanted. So if you wanted to model the incompatible versions of libc++ because you want to have some binaries built with the stable libc++ and some binaries built with the unstable libc++, you can probably customize the triplets and to model that, no problem. So VC package will be able to handle that. To me, that's new. Although, what I found interesting is, in spite of the fact that for the past 10 years we have allegedly ABI compatible compiler runtimes and things like that, they still default to building from source to ensure maximum compatibility. So all of these things that I've been showing you that are happening to some developers, there's a chance that like a lot of developers are not experiencing it at all because they are building from source regardless. So again, trade-offs of building from source, and if you're able to do that, but we're already living in a world that a lot of developers are actually not experiencing the disruptions. Conan is slightly different. So instead of having the concept of triplets, we have the concept of profiles that describe the platforms that you're targeting, right? So we have some of the settings that go in a profile are the operating system, the compiler version. Something that we have added in Conan 2 is as mandatory, is the compiler C++ standard. So the way Conan works is that any variation in some of these variables is going to result in a different binary package in the Conan cache. For a given library, Conan actually treats, if they're built with different compiler versions, they treat them as different. So Conan by default, if you're in, I don't know, if you're on Mac OS with Apple Clan 17, is not going to consider binaries built with Apple Clan 16, even if they are compatible. Just Conan by default doesn't do that. You can very much configure Conan compatibility modes, so you can get Conan, hey, please consider, because I know Apple guarantees that they're compatible, like binaries built with earlier versions of the compiler. And you can do the same with Windows as well. But we have found this as a good compromise as well, to say at least gate them by the compiler version. What we introduced in Conan 2, as I was mentioning, is this was a very much requested feature by Conan users, which is I want them to build some binaries with to force the version of the standard that I'm building them with, right? And which leads me to this discussion here. I've been in teams in the past where whenever we were advancing the version of the C++ standard that we were using, I was told, hey, Lewis, we need to build all the dependencies with C++. Well, back in the day, it would have been 17. And I was like, why? They are supposed to be ABI compatible. We shouldn't have to. But then again, I just showed you earlier all the issues that can happen. So I used to be on the left side of the discussion. Now I'm probably more on the right side of the discussion, because in a lot of cases, that actually guarantees like fewer or less probable linker errors, right? But in Conan 2, what we've done actually is the compatibility mode around the C++ standard. So if I'm installing a recent version of Boost and I'm working with C++ 17, right? Conan is actually going to look, if I don't have binaries built for that in my local Conan cache, it's going to check against the Conan remotes that I have configured. And it's going to check, hey, do you have it built with C++ 14? Because I'll take that one, right? And this is the way we model that compatibility that the compiler vendors guarantee. But what do we do with Upside? The reason I ended up in the Upside compiler and linker errors before, it was because Conan was actually considered incompatible. So what we can do for libraries like Upside is in the Conan recipe for Upside, we say, hey, you know the compatibility for the C++ standard? This library doesn't do that. This library is fully incompatible across C++ standards. So Conan now will only consider binaries for Upside for the specific version of the C++ standard that you are requesting. And for additional safety, we add for the consumers of Upside a guarantee that if you're building protobuf with a version of the C++ standard that is not the same as Upside, it's just going to show an error. Why is this? Because in Conan, you can actually tell Conan, hey, build this recipe with C++ 14, but this other one with C++ 20. It's not usually the default way, but we have the flexibility. So in this case, we added those lines to actually show an error to the user so they don't waste their time dealing with linker or compiler errors. And if you tell Conan, hey, we now go from the issues that we were seeing with Upside, the compiler errors, the linker errors, and things like that, to we support multiple ABI incompatibilities built of Upside, right? And instead of having errors in linker or compiler, Conan is either going to tell you, hey, there's a missing binary for maybe gRPC or AppStyle for the request and configuration. And if you tell Conan, build it from source, it's just going to build it from source, and it's going to work, hopefully. Unless you're trying to mix and match manually. In that case, it's actually going to tell you, hey, what you're asking is not possible. And this is something I wanted to illustrate, because it is true that we've had, for the most part, ABI stable C++ runtimes for the past 10 years or so. We're talking Visual Studio 2015 and GCC 5. But Conan and VC package or even semi-fetch content didn't really exist before then, or were not really that popular. So I'm thinking that if we had a new ABI break today, people using these tools are probably not necessarily too exposed to the issues. And at the same time, like, I know some developers, they actually use pre-built binaries, and therefore they would need to ask their vendors. But vendors also have now, because of the tooling, the ability to target the platforms that their customers need. And it's much easier than before. For Linux, again, with all its compatibility challenges, we have Docker now. Docker was not necessarily that popular back in 2015. Visual Studio, the licensing model has changed as well. I think for the better since then. I think now it's probably free for small teams, and they've been really good at like bundling the older tool sets with the newer versions of the of Visual Studio as well, which I hope they continue doing if and when they break the ABI. So that's actually, you know, things that we didn't have necessarily back when the last ABI breaks happened. So some thoughts and conclusions about this. Obviously, while we had the big ABI break disruptions 10 years ago, we still have disrupted link incompatibilities that never actually went away. And I'll just show you a list of those that most of the ones that I show you, actually we experienced in my team or were reported like in the last 6 months, right? Or maybe the last year or so. So as far as I'm concerned, and perhaps we're more exposed because we're in Conan Center as well, and we deal with like making sure that people have compatible binaries for their build, it's still happening, right? There's also, and I didn't discuss it here, take any long enough period of time, and there's going to be things that have nothing to do with C++ that are going to force you to rebuild anyway. Maybe Apple will decide that they abandon Intel and all of their laptops and the computers are going to use a different CPU architecture. That's the thing that has actually happened. So you're going to have to, eventually, you're going to have to build from source anyway. It is possible to actually retain long-term backwards compatibility that comes with some trade-offs. Like, I could choose to use a really, really old binary that I have been like carrying for, I don't know, 20 years or so, if I disable position independent executables, if it's a static library, or if I force to the compiler to use the pre-C++11 ABI as well. So compilers have been really careful to actually enable that as an opt-in if you need it. And then lastly, I think personally that when it comes to the tooling that people are using now, it will be a lot easier to, like, a lot of people don't experience these incompatibilities because they are able to build from source even across different build systems and things like that. So that's easier. But on the topic of building from source, I'm going to conclude with this. Obviously, the solution to most of the problems that I've shown you is you have to rebuild something from source, right? And that actually works. Oh, you have to rebuild it with the same version of Visual Studio, or with the same flags, or with this, yeah, with the same flags, with the same standard version. But not everybody can do this. There are people, developers that are using closed source libraries as well. But like I mentioned, I think even software vendors are in a much better position to provide the binaries as the compilers are updated or new standard libraries are provided. And by all means, you should probably have a good agreement with your supplier so that when that happens, they're ready and you're not disrupted. And also, I'd just like to point out from the annual C++ developer survey that the library source code for third-party dependencies, the first response year after year is the library source code is part of my build. So I don't necessarily like it, but if you're doing this, or if you're using Conan or VC package, it does enable you to build from source if some of these things change. But not only works and not only protects you against ABI incompatibilities, if you can actually build from source. And bear in mind that this is actually a design goal of the C++ standard, right? And the wording that they use here is, in my opinion, like very strong guarantees, 100%, seamless, friction-free, must always be available. It should be like source compatible, right? But then we get things like this, reported in Content Center, which is all these libraries, like one of our contributors tried to build with C++20 and they were getting failures, right? It could be small things. It could be that it's actually old code that was not updated and they're using a keyword that is now no longer supported, but it does actually happen. For me, I think that would be a topic for a whole different talk, right? Unlucky for me, that talk has been happening in a separate room right now, as we speak, so I'll catch it on YouTube, I guess, once it's published. But thank you so much. This concludes my talk. Cool. Any questions?
No, first of all, thank you so much for this great talk. I really loved how you did this, how you basically categorized and did the work to identify. And so first of all, nice to meet you. I'm Library Evolution Chair, the group in the ISO standard that is in charge of standard library. So nice to meet you. I did wanted to highlight two things actually. First is that when we talk about ABI compatibility in the standard, it's when I define the struct, for example, and define its members, it's not necessarily the ABI compatibility of different implementations can do other things as well. So I guess maybe it would be good to do this separation, but I do agree with you on the general note of, there are the issues that you floated exist. And I also wanted to thank you, for actually identifying or the tagging aspect of like tagging the version, tagging the compiler, the ABI version of things. I think that's the way forward. I think it's really, really useful. And I think, us as an industry of, software develops over time. And I think that's really great that feature that you showed of Conan is exactly the way that we can move forward. But anyway, I just wanted to thank you, first of all, for the hard work of collecting those. I thought it was very insightful. And second, to thank you for the solution that you've been working on.
Awesome, thank you so much.
Thanks, Louis. Terrifying talk. As a library maintainer author, what can I do to be a good citizen in this situation?
Good question. Well, first of all, I think you have to choose whether you actually want to provide like ABI compatible libraries to your users, right?
At least I've got the headers.
So have a look at the concerns of the standard library maintainers. Like there's very good documents and papers about this and talks, I think, as well. Like if you want to provide this as well. A lot of developers are not even aware of this, right? They're not aware that if you change the order, I think, of like virtual functions or something like that, you can actually cause an ABI break. And I've seen the FNT library, I've seen a couple of involuntary ABI breaks across releases that were fixed afterwards. So they do happen. So I think there's some tooling that you could use to detect ABI breaks in your CI. I'm not sure if they like good with C++. I think Abigail is a tool or library that can be used. So I'm trying to explore it as well for Content Center to detect whether we have these issues to avoid them happening in the first place. So
Thank you.
no worries. Any other questions? Awesome. Oh, one. Brett.
Yeah, 1 minute. Right.
This might be quick. How often do you find yourself patching packages to work around ABI issues like hard coding the standard flags or vendoring in something that shouldn't vendor or something like that?
We do so because Conan users now, at least Conan 2 users, expect the libraries to be built with a specific version of the standard that you tell them via Conan, right? We have to patch a lot of libraries that hard code in the CMake, so that's very frequent. ABI issues, it's tricky because, as I show you from the linker error, sometimes it's not evident that it has to do with ABI problems. So we need investigation. So The actual gRPC one, that took me like a whole week probably of experimenting things, but it's quite every few months, I would say.
You showed that statistic about most engineers claim to copy their dependencies source code into their projects. And I just wondered if that caused problems within like Conan packages. Like, oh, I just put my project into Conan and it includes the source code for protobuf or something. So I don't have any problems, but all my users do or something like that.
We try to not in Conan Center to not have like vendoring libraries as well. Right. So hopefully that mitigates the problem. But yeah, it's only compatible if the libraries themselves are ABI compatible. And then again, it takes somebody researching the linker error because we don't know beforehand.
Thank you.
No worries.
Hey, nice talk. So over the Beeman project, we've had a long conversation about this issue, specifically what we call flag forking, which is those options that you were talking about, creating a potential ABI incompatibility. And also the idea that your CMake would, say, set a certain version of the standard, right? And so we've taken a very strong position that your CMake for your library should not ever set that C++ standard. And so what we're basically doing in the header, at least this is some of the libraries, it's not 100% consistent yet, is if you require C++ 20, which most Beeman projects actually do, because they need concepts essentially, you'll just fail to compile. So if somebody just takes your header-only library, for example, and drops it in their project and they don't have their settings, because see, the flaw in the thinking of doing it all in the CMake is basically that they're going to use your CMake. Even if they're using CMake, they might have their own CMake and their own setup. The same thing with those options and flags. So you showed a slide where you had the, has include.
Yeah.
I think at least where I've gotten to personally, I'm not sure the whole project is on this yet, is that that's totally valid. It's just that in the header, the library should set defaults that it makes sense. And then if the user wants to handwrite that options.h for their project, they're free to do so and override the defaults. And I think that's the best practice. You tell me if there's a better practice.
No, I fully agree. In fact, what you've described, what you're doing via headers, that's what Conan does via the configuration. So I know that you could have a CMake file that uses the compiler feature flags that will force the consumer, if they're on an earlier version, like bump them to the newer one and transparently, and they don't even have to do something about it. Conan is different. Conan, what it will do is it will tell you what the minimum is, and in some cases the maximum, because we've seen that way as well. And if you're outside of those bounds, it will, on the consumer side, will give you an error, and then you have to figure it out, including sometimes not having a solution. But we will not force consumers to change their C++ standard level without them knowing. That's not to say, they decide.
Right. Yeah, no, exactly. I think that's a real problem. And so the last thing I'll mention is if anybody knows about vector.
Up in the hallway.
There's just one comment.
We're already 3 minutes over.
Okay.
Sorry, yeah,
So,
we can continue.
Yeah,
afterwards.
Vector of Boole has a great blog post on this, just saying.
I'll have a look. Thank you so much. Thank you.
Thank you.